Okay, let's talk more about inverse functions. Inverse relation is obtained by reversing each order pair. So in class we talked about if there is a coordinate a comma b, then the inverse relation of that will be b comma a. Okay, so the first thing I'm going to do is in green, I'm going to plot these 4 points, 1 comma 3, 0 comma 2, negative 2, 2, and negative 3, 1. Okay, well, because I know what inverse relation is, right, we just have to reverse the order pair. So the inverse relation of C be 3 comma 1, 2 comma 0, 2 comma negative 2, and 1 comma negative 3. Okay, so I'm going to plot these points, 3 comma 1, 2 0, 2 negative 2, and 1 negative 3. Now notice the inverse relation here is not a function because there's 2 values of y for this when x is 2, but that's not what we're focusing on right now. So if I were to draw this line, y equals x, there, then you see that these points are a reflection of the line y equals x. This green line is y equals x. Okay, so what this tells you is given the graph, you don't have to find the equation of the graph, equation of function, or just from knowing what the graph looks like, you should be able to draw an inverse function or inverse relation of that. So how do you algebraically find that? So the first thing you have to do is exchange x and y, and then solve for the new y, and replace y by f of negative 1. Okay, let's do an example. So here, this is the same thing as y equals x minus 5 cubed minus 2. So I'm going to exchange x and y. X equals y minus 5 cubed minus 2. And then solve for this y now. So add 2 to both sides. Cube root of both. And then add 5. Then the last step is replacing this y with f inverse of x. F inverse of x would be cube root of x plus 2 plus 5. So what does this mean? Why do you even care about this inverse function? Well, maybe this will help. So here, what is f of, say, 3? F of 3, that means substitute 3 for x in this expression. So 3 minus 5 cubed minus 2. 3 minus 5 is negative 2. And negative 2 cubed is negative 8. Minus 2 is negative 10. So if you plug in 3 for x in f, then you get negative 10, right? But now, check this out. F inverse of negative 10. That should be 3. So what is f inverse of negative 10? Well, I'm going to use this expression. Cube root of negative 10 plus 2. Again, cube root of negative 10 plus 2 plus 5. And cube root of negative 8 plus 5, right? And that would be negative 2 plus 5 is 3. So hopefully this helps you understand what this inverse function does. So if I asked, hey, what is f inverse of 7? Then you have to say, you have to think about, okay, what was the x value here such that I got 7 for the y value in the original function? So that's what that means. Okay, let's do another example. Here is a quadratic, x squared minus 10x, and there's a given domain, x has to be greater than or equal to 5. So I'm going to think about a graph. So what does it look like? So there's my x and y axes, and I know that I'm only interested in this graph to the right of 5 or on. Let's see, x times x minus 10. So I know the x-intercepts are here and 10. Okay, and it's going to open up. So all I need to know is, well, I know the axis of symmetry is going to be right there, but just know where in this region my vertex is. So the vertex is going to happen when x is 5, so I can substitute 5 in there. What is f of 5? 5 squared minus 10 times 5, it's been negative 25. So somewhere around there, 5 comma negative 25 is my vertex. And I'm only interested in the side on 5 and to the right of it. So that's my function f of x. Okay, so I am looking for the inverse of it. Well, the range of this function is quite important because that's going to be our domain of our inverse function. So what is the range of this function? Well, here is y equals negative 25, and y values are bigger than that, so y has to be greater than or equal to negative 25. And that's our domain of the inverse, and we're going to find that now. So let's go ahead. X equals y squared minus 10y. Okay, now what do I do? I have a problem because there are two y's now. So what I'm going to do is I'm going to complete the square. If you didn't know how to complete the square, then there's another way. Or if you don't want to, what you can do is because you know the vertex and you know the a value is 1, you can simply just write this function in vertex form, and that would be the same. So you've now completed the square, right? Or at least you got to the same place. Now I'm going to solve it, or exchange x and y. So x equals y minus 5 squared minus 25, and then solve for y. Square root of both sides. And then add 5. Then finally, f inverse of x is 5 plus or minus square root of x plus 25. Okay, so in the domain would be x has to be greater than or equal to negative 25. Because if x is less than negative 25, this would be inside the square root would be less than 0, and you can't have that. And also, you wouldn't want so here, you remember this used to be a quadratic going up this way, and you're only taking the right side here. And if you were to reflect this over y equals x, it'll just be the top part here. And you don't want it to be plus or minus. You just want the top half of it there. Okay. Now that was a tricky question. It's a lot easier if you complete the square first, or put the quadratic in vertex form. All right. So here's another important fact, that the composite of the function and its inverse is the identity function x. So they both have to be true. And let's check that. So let's say f of x, we already know, is x cubed minus 2. And let's find f inverse. So I'm going to do x equals y cubed minus 2. X plus 2 is y cubed. So cube root of x plus 2 is y. So f inverse of x is cube root of x plus 2. Okay, so now that I know the function f and its inverse, I can check both a and b. F of f inverse of x. So f inverse of x. So in here, every time I see x, I'm going to put this function in there. What is that going to do? Cube root of x plus 2 cubed minus 2. Notice that here, that was my x, right? Then, cube root of something cubed is going to be something that's inside, minus 2, so that's just x. Let's check this one. I'll use red and squeeze in the middle here, f inverse of f of x. So in this function, x here, I am going to substitute this whole thing. That's going to be cube root of x cubed minus 2 plus 2. And that's going to be cube root of x cubed, which is just x. So we've checked, it's not proof, but we've checked, at least we have a good idea that this is true, and that's enough. Let's look at this example. Well, there are a bunch of examples. So earlier we talked about what this meant, right? So what was, this means, well, g of something is 2. What was that something, right? That's what this is asking. So you go to g, it says, what was the x value that gave you 2? That was 1. So there you go. G inverse of 2 is 1. The same thing here. What was g of what gave you 1? Oh, over here. That's 0. And let's do the same thing with f. F inverse of 1. So here we don't have this ordered pair. So this was easy and nice. This one, we don't have that. So let's change colors here. For number 3, I'm going to say, all right, that's my output, right? So then I can replace f of x with this. So 1 is 1 of x plus 4. And then I can just solve for x. So subtract 4 from both sides, and then multiply by 2 to both sides. X is negative 6. So there's negative 6. There's another question just like it. So y value, f of something, is negative 3. What's the x value? Well, let's solve it. Negative 3 is 1 half x plus 4. Solve for x here. So subtract 4 from both sides. And then multiply by 2 to both sides. So that's going to be negative 14. Now the last two questions, we don't need to do anything because this is a composition of the inverse and the original function. So here we talked about that composition gives you identity function. So this is going to be 5 and this is going to be 2. Okay, I know that was real quick, but here's a summary of what we talked about today. Inverse is a function is obtained by reversing the coordinates of every point of x and y. So 2, negative 3, for example, will be negative 3, 2, and every single point will be reversed that way. Graphically, this means that the original function and its inverse will be a reflection over this line y equals x. And algebraically, we find the inverse by switching the x and y and then solving for y. And don't forget to write the final expression as f inverse of x instead of leaving as y. And then here's an important thing that might not play a big role in SL, but is still worth remembering, is that because you're switching x and y coordinates on all the points, your domain and range will switch. So domain of the original function will be the range of the inverse function, and the range of the original function will be the domain of the inverse, and so on. Okay?